So shear force and bending moment diagram for cantilever beams. What is a cantilever beam? A cantilever beam is one that is just supported at one end. So as you can see here, this beam has a rigidly fixed at this end, and it has a load of 5 kilonewton applying at the very end of it. So it's a 2-meter beam acted upon by a 5 kilonewton load. So let's go back to the basics. So in order to create a shear force diagram, you need to have all the forces acting on it to be zero. So we have discussed in a few of our previous videos that the equilibrium of a beam is by summation of all the forces in x direction equal to zero, summation of all the forces in y direction equal to zero. That's a force equilibrium of this beam. So you can see there is a 5 kilonewton load acting downwards, and the only support for this beam is at this end, which is a rigidly fixed end here. So all the equilibrium force for this load should come from this support. So let's name the ends as A and B. So you have a force of 5 kilonewton at B and a reactive force of whatever the magnitude is at A. So for equilibrium, there is no axial forces, so there is no forces in x direction. So that's your x direction and that's your y direction, and there is no forces in this direction. So that's a forces in x direction is zero already. So only you need to worry about forces in y direction. So in order for this to be satisfied, you need to have 5, because it's acting downwards, that is minus 5 plus RA equal to 0, and therefore reaction at A is equal to 5 kilonewton. So once we have the forces on either side, you can draw the shear force diagram. So I have already created the shear force diagram here for you. So you have a datum line which has a 0 Newton force here, and at this point you have 5 kilonewton acting downwards. So your shear force diagram starts like this, goes all the way down to 5 kilonewton and up until this point there is no change, and at this point you have a reaction at A equal to 5 acting upwards. So your net force becomes 0 at this point. So that constitutes your shear force diagram. That's your shear force diagram for that particular cantilever beam. Now, to draw the bending moment diagram, you need to create a bending moment equation for this beam. So let's consider a section of the beam. Again, going back to the basics, take a section between the load and the reaction. So let's call this section X, and we're going to create a bending equation for that section. So we're going to take the moment about this point. So let's say moment about X is equal to the load acting is 5 kilonewton downwards, creating a clockwise moment, and therefore this will be treated as a negative moment, and it is acting at a distance x from this section. So section x. Now moment about x will be 5 kilonewton is the load and the distance is x. So that is your load and distance. So you get 5x is your moment. That is 5x, and you need to give values for your x. So you have a x varying from 0 to 2 meter. So at x equal to 0, your moment is equal to 5 times 0, that is equal to 0, and at x equal to 2, which is the maximum value for x, your moment is equal to 5 times 2, that is equal to 10 kilonewton meter. So 0 and 10 kilonewton meter are your limits for bending moment. So you can create your bending moment diagram from this information, and because it's a linear relation, as you can see, it varies linearly with x. There is no power to x in this equation, so it's a linear relation, and therefore it's a straight line. So you get at x equal to 0, which is this point, the bending moment equal to 0, and at x equal to 2, which is this point, the bending moment equal to 10 kilonewton meter. So you create a straight line from this point here to this point, which is 0 here and 10 here. Obviously, it's a bending moment generated by, or moment generated by the support equalizes this to 0. So that constitutes your bending moment diagram for cantilever beam. Always remember, the cantilever beam will have a moment at the support, unlike other beams where the bending moment will be 0 for a simply supported beam at both ends, whereas for a cantilever beam you will most likely end up with a bending moment at the support, because it is the support that is providing the equalizing bending moment for this beam. So you will always have a bending moment here, whereas for simply supported beams, in most cases at the supports, the bending moment will be 0. So that is the first video for bending moment and shear force diagrams for cantilever beams. Keep watching for more videos on cantilever beams. Thank you.